Today we are here to talk about the course project of ours called as the course management system, which we have developed for the startup called as the TrainLeader.io. It is an alternative to the expensive education system that we have, where we have to shell out thousands of dollars in tuition fee in order to obtain formal education. Here we are offering an alternative where students can enroll, study, and also gain certification for the knowledge that they have acquired. What actually that we are doing here is that it's a platform which offers the users to register onto our system. Students can enroll into different courses. They can interact with the faculty members who are going to teach those courses, and then they get to ask questions, share those questions and answers with their fellow students, and get them clarified with their faculty members. And there's a way that once they have completed all their course materials, they also get a chance to obtain the certification. Some of the features that we've implemented here are that an admin can register a new user onto the system. An administrator can authenticate not only faculty members but also their fellow administrators. Based on the student's ID, our application is going to provide a list of courses that are specific to that particular student, depending on whether they are interested in it, whether they have completed it, or they have enrolled in it. And the next one is that a student can, enroll into the course by themselves. The application can also be utilized in order to mark the completion of the course material. Once they are done with it, they can just mark it as complete, which leads them towards the completion of the course in turn. The further features will be covered by my fellow teammate Baja. Over to you.
Okay, the features implemented continued. It also have that our application can be used to list the completed and incompleted materials about the student enrolled course that is ordered. After that, student has completed all the materials and paid for the course, then the student will receive a certificate of the completion. Our implement features also include based on the student ID, the student can obtain their account history to get the payment code, payment date, and the cost of the course. Okay, we also have the additional functionality implemented by our team. First, we added a user-friendly interface to our database project, and we sanitize the user input to protect the database from SQL injection attacks. In order to secure the user password in the database, we use the encrypt algorithm, and we listing all the introductory level courses. Also, we list the user transferred by the country and the question based on the number of likes. And we quiz the question graders. Additionally, we use the average function to calculate the average time spent on the courses and list the most curious students. The last one is that we quizzes the offered as course material with grading. So next part, my teammate Vinny will introduce to
you. Hello. Now I'm here to give an idea implementation of system architecture in our project. So in our project, we use SQLite 3 as a database management system, and we all consider the parameterized inputs from the users and process them to the raw queries, which is specified all in the views.py file in our web application. And this all interaction between the front end and the back end and all is written in Python. And for that, we use different libraries to satisfy. For example, Jinja, Flask, Forms, everything to just make the front end look more dynamic and create the forms on the fly. And we also use this another Python library called bcrypt, which encrypts the user passwords and make their login secure enough so that hackers can't. It makes it's tough for them to breach into our database. Moving on, we also have this Travis library, which is a continuous integration feature, which is being implemented in our web application. And all the libraries and the packages which we used are being interact with each other using the Flask web framework. And further implementation of our project is discussed by Alex.
Some of the key design decisions that we made in our database, I'll explain those. So the first decision that we came upon was the decision to semantically understand the difference between completing a material and completing a course. Even though someone might complete all the materials in a course, we wanted to understand that differently from actually completing the course in case updates to the former would affect the latter. So that's the first design decision that we made. We also semantically wanted to recognize materials as being weak entities. And the reason we did this is because we knew it was a requirement to store the order of the materials in a course. And if we were to have them as strong entities, then we would have to also store as an additional attribute the order of the material within the course. Whereas if it's a weak entity, we can just use the material ID for ordering. And as you can see, I'd like to point out this additional bonus feature. We also implemented quizzes as a fourth type of material. Next. After the database ERD design, we wanted to design the logical mapping of our database. And so we encountered more hurdles here in our design process. The main one that I remember here is that when we were implementing topic, we had to decide how we would store a primary topic for every course while also having multiple secondary topics optionally. And the way we implemented that is by having courses store a single topic ID for the primary topic, and in order to store multiple secondary topics, we have a separate relation. And I believe a lot of our mapping resulted from us having a lot of relations in our database, and we ended up converting a lot of those, just following the regular algorithm, into these small tables which just link up various of the strong entities. And after we were done with the mapping, we created the physical database using some DDL and DML to instantiate the data. And while we were doing this, we were not only careful of the explicit constraints that we listed in that DDL, like foreign keys and default values, etc. We also had to pay attention to the business logic. Things like a user cannot complete a course if they haven't enrolled in the course yet. And those are things that can't easily be encoded into the database structure schema. So we had to keep that in mind as we were instantiating the data. Thank you.